Welcome, everybody, to the panel discussion on AI in production, reliability, and safety considerations. That's quite a mouthful. This is day one of the Metadata and AI Summit. As you probably saw, we had a couple of really great talks to start out the conference. And I'm really excited today with the panel we've got here today. I'll be your moderator. I'm the CTO and co-founder of Acral Data and the founder of the Data Hub project. Prior to this, I was at LinkedIn for 10 plus years, where I led data platforms and developed solutions for data democracy, privacy, and also AI infrastructure in some cases. And so I have some insight into some of the complexities that we'll be talking about today. But really, it's my pleasure to welcome all our guests to this panel. Some of them are repeat offenders, shall we say. Acral Data, started in 2021, and prior to that, I was at LinkedIn, where we hosted our first metadata day. Back in the day, it was a single day event. In fact, half-day event where we did a panel. Joe and Teresa were on it. And then we repeated that tradition over in 2021 and 2022. Took a brief hiatus in 2023, and we're back in 2024 with a two-day conference this time. So I'm really excited to welcome back Joe and Teresa to this panel. And new folks, Deepak, who I worked with for a few years at LinkedIn, and Alex. So here's what we'll do. We'll go around the table, the virtual table, and introduce each one of you. Of course, I've already introduced myself, Shashank Das, but let's start with Teresa.
Hi, I'm Teresa Tung. I'm our Global Data Capability Lead at Accenture, and really happy to be here again.
Let's go over to Deepak.
Yeah, hi, I'm Deepak Agarwal. I'm the Chief AI Officer and VP of Consumer at Pinterest.
And Deepak, you have to choose a side. I'm sorry.
So I grew up as a scientist, AT&T Labs, Yahoo Labs. I've followed Jeff Hinton all my life. So this is a difficult choice, but I'll always go with Jeff Hinton.
All right. Okay, continuing on the grid that I have in front of me, Alex Demakis.
Hi, so I'm Alex Demakis. I'm a co-founder and chief scientist of Bespoke Labs, and I'm also a professor in the University of Texas in Austin, where I've been leading the NSF Institute for the Foundations of Machine Learning. And you want me to pick between profit and safety?
Yeah. As a CEO of a new company.
Okay, so I'm actually in the middle. I think that Jeff Hinton has been raising a lot of important points, but I think also too much regulation can be a huge problem, and we're seeing that in other ecosystems. So I will play the middle, being in the middle card.
Wait, I thought you can't choose.
You cannot choose.
I just did. Good luck.
You have to choose one. Well, you have to choose one. Sorry, there's no independent party here.
Anyway, yeah, I would have to, if I have to pick one, I would have to pick Jeff Hinton's side, but I'm really in the middle. That's really the reality.
Got it. Okay, and last but not the least, Joe.
Hi, I'm Joe Hellerstein. I'm starting my 29th year on the faculty at Berkeley. I'm also an entrepreneur. Most recently, we have a company called Run LLM that is a tech support agent company. And I think if I'm forced to choose, I'd better be consistent and say profit, because I'm trying to make money in this space. And it just would be honest if I said otherwise. But really, Shashanka, in these difficult times, the idea that you're trying to divide us into separate camps really, isn't, I think, our future.
I mean, it's just getting you prepped for what lies ahead. Let's just put it that way. All righty. So we've talked about everyone here. What was interesting was just before getting on this panel, we were kind of trading lineages. And turns out Joe and Alex actually do have lineage to the University of Berkeley, and they kind of found a nice mutual connection. So that was cool to watch. But let's move on into AI systems. And one of the things that I see repeatedly is a lot of optimism, a lot of energy around AI, and putting and those initial demos. In fact, we recently did a demo of an AI chatbot that could talk to your metadata and kind of give you answers, and it was pretty nice. And it was very hard to build it, and it's still demoware. I demoed it at Town Hall. It's been a month. I haven't still been able to push it to production. And there's a bunch of things that got in the way. So I wanted to kind of pose this question to this group. What do you think are the most critical challenges that get in the way of ensuring the reliability of AI systems, from prototyping or research to large-scale production deployments. And Deepak, as with your history working on productionizing AI, both at Yahoo and then LinkedIn and now Pinterest, I think you're like one of the best experts to take a first crack at this question.
Yeah, I think. Thank you again. Thanks for that question. Yeah, again, this is something. After my history at Bell Labs, again, I was a scientist. Did not appreciate everything that goes into industrializing scientific solution, and so the last 15, 20 years I've learned a lot. So yeah, I think, look, there are two broad classes of applications even when it comes to AI. One is the pure backend use case, right? Like, you kind of create signals, you create models, and you deploy it, but it's not user facing or customer facing. And now in the world of Gen AI, it's become very relevant. Like, there's a lot of user facing applications that actually show output of AI. And so this becomes even more challenging, right? So some basic things that are always a challenge. One is robustness and scalability of your solution, right? So you can build something in the lab, but how do you ensure when you're putting it in production in the wild, it is industrialized, it is robust? Very basic things like training pipelines running on time, data quality, feature pipelines not going stale, observability on each of these things. If something will always go wrong in such complex systems, especially in the deep learning era, back in the days when you're doing GPT and all, it was much simpler. Even these challenges existed back then, but now with the deep learning era, where there is so much data involved in building such large models, these things become even more important and more challenging. And having something like a graceful degradation in the system, this is also very important. Then you have very different kinds of model all running in production. Like if you're looking at a general recommender system or search system, you have the retrieval layer, and you have the ranking layer, you have the blending layer. Each of these layers have very different models. Some are simple, some are complex. They have to all come together. There are interdependencies. So how do you manage all of that in a way that is robust and does not degrade the system? Because once you degrade the system, all the ROI you got from the AI is lost, right? And so this is extremely important. The other thing is adaptability, right? There will always be shifts in the ecosystem. The world is changing, the data is changing, how users interact, customer interaction. So the models have to be adaptable. That is kind of something that has to work in practice. Feedback loops are important. You launch something, the first time it works well, it creates a bad feedback loop, and then the whole model tanks over time, right? So you have to be careful of these things. When you're doing an AUC curve on test data, it doesn't matter, but when you're putting it in production and the whole process is sequential, this becomes extremely, extremely important. Similarly, you are always changing the UI. If you're a customer-facing app, the UI is always changing. The way you collect feedback is changing. How do you adapt your models to that? This was a big challenge for me in the early days when I was at LinkedIn. Like you, Srishanka, and you remember, right? Like, we used to struggle with this every day because the whole logging has to be changed and the pattern has changed, and whatever was working earlier was not going to work today. So the other thing is also metrics, right? So when you launch a model, often, you test your model offline. There are some metrics that give you the quality of the model. But in most cases, the offline metric and the online metrics, they don't always correlate very well, right? So what are the right metrics to kind of improve the speed of innovation where offline and online can be in sync with each other? And even if you do all of that, a global metric is not a good measure of the entire system that the model is supporting, right? Like, I'm giving an example from LinkedIn because now I'm not there. We used to have these cases where we will launch a new model and the job recommendation would improve by 10%, but then someone started seeing an intern recommendation when they were a VP, right? So there were always these stray cases, and that erodes trust in the system. So you can't ignore that, right? So what's the right metric? What is the right relevancy? How do you measure it? This is always a big challenge. And now if we look into the era of Gen AI and agentic AI, which is the bar has gone even higher, right? So because the output is now something you show to the customers, right? So if you show an output and the description is objectionable or not good, then things can go very, very wrong, right? So, and one thing to realize is Gen AI models, foundation model, are primarily trained on positives only, right? So when you're predicting the next word, you don't have a negative example. So you're training on a large amount of positive labeled data, and anything can go wrong because you've not even trained the model on negative data. So things can deviate in a very wrong way, in very spectacular ways that you can't even predict, right? And we have the term hallucination for that, but
Yep.
the hallucinations are very different for different applications because everything is trained on positive. There is absolutely no negative. So a lot more rigorous testing has to be done when you're launching these models. It's like in the early days of airline, right? When airline was just discovered, it was very risky, and so you have to put in a lot of tests so that airlines become safe, right? And so that's where we are with Gen AI in some sense, right? And the data that goes into this Gen AI model is also a very important consideration. Like, do you have the rights to train on that data? This is becoming a big issue nowadays, right? Are you compliant, and do you have adequate security controls? Do you have if you are doing agentic AI? What about the contracts among different agents? Is it all good? Is it all secure? So these are very important considerations. I think it is important. So to use the metaphor of a railway, it is important to lay down the right guardrails so that you can launch your high-speed AI train on the rails itself. Because if you don't do that, your efforts could go very off rails, right? And so that's where we are with Gen AI. And finally, last but not the least, this is probably the most important thing for business leaders. Maybe as technologists, we don't think sometimes a lot about it, but nowadays we have to all think about it: the cost. The cost of deploying AI in practice and the ROI you get out of it, right? So you can build very large models, but if the ROI is not supportive of the cost that you're incurring, or even the human cost you're incurring, it's not going to survive at the end of the day, right? So you also have to be
Contact with the.
Anyway, so these are some of the thoughts.
Well, there's a lot packed in there. Probably a 1 hour long masterclass packed into maybe 5 or 6 minutes. So that was amazing, Deepak. I heard a couple of things. Time kills all bad models. Second, guardrails are important, and I bet Alex has a bunch to talk about there. So maybe I'll hand it over to Alex. So tell us a little bit about guardrails and what you're seeing as critical challenges ensuring the reliability of AI systems.
Yeah. So as Deepak said, there is a lot of problems. We're just building the train as we're inventing new engines, and putting them on top of the train. The time scale actually that these things are going from research to demos or production is incredible. I think the problem is, of course, that LLMs don't know your data sets. People want to do Q&A on their data sets, and somebody says, how do I install the printer? And it needs to know what's your printer, and it says it needs to know your VPN settings. So basically, everybody wants personalized models, ideally small personalized models. How do you put your own knowledge into the LLM? The simplest thing is retrieval. You just add some paragraphs in the context, and everybody started with that. Everybody's realizing that doesn't work very well right now, or even they're realizing, as Deepak said, that we don't even know if it's working very well. So there's a lot of work on evaluations. Sometimes the evaluations lie to you because the model has memorized the evaluations. So there's a very challenging issues about how do you evaluate, how do you build the guardrails. So we are working on detecting hallucinations, which is one small model that does one small job well. And in general, one thing I believe into dealing with the complexity here that I think other people have spoken about is I don't think people want one big LLM that just does everything. I think people want to build systems, and systems are built by making small, reliable components that different teams are responsible for building and checking. And I think that in the future, we will just have small models that is like one model is doing checking for hallucination, another model is doing another small job with predictable inputs and outputs. And then to build those systems, you need to have data curation for this specific problem. So another key problem we're seeing is that to create those data sets for doing fine-tuning or continual pre-training or RLHF DPO, you need to have the data sets in this right form. And I think a lot of companies are having very hard time, and they're just training on raw data, and they get models that just hallucinate new manuals. Like if you train on manual text, you're just going to get a model that produces fictional manuals. You need the model to be trained on questions and answers in the style of your users, not in fictional text. So the transformations in the data sets is one of the key pain points we see, and the guardrails and evaluation is the other.
Cool. Data quality, data lineage, and I guess being able to find the right data set to even train your models on seem like things that we hear about a lot as well. Joe, you've kind of gone from academia back into starting a company, and you're taking research into production yet again. So tell us about how your experiments are going and what challenges you guys are facing as you take Run LLM to the masses.
Yeah, sure. One of the things I'll point out is a couple of our amazing PhD students, Shreya Shankar and Rolando Garcia, went out and interviewed a whole bunch of ML engineers a couple of years ago and wrote up a paper on their interview study. So a lot of our learnings are from going out and talking to lots of people in the field. That's been super helpful. I'll just make sort of 3 focus points here to try to put some there's so many things to talk about. So I'm going to pick 3. The first one is indeed iterating on data quality. So what we find in the field and what we absolutely see at Run LLM is, yes, you do fine tuning or you do some model engineering, but mostly what ML engineers are doing in the field is iterating on data and data pipelines. So very important that you have well-instrumented data pipelines, that you can iterate quickly and that you know what's going on before things hit the training phase. And then as the feedback loop happens and then you're getting information out on your quality and your metrics, that data pipeline also makes sense along the way. And so these are things that continuous integration techniques and so on are very important for. The second thing I'll point out that came up quite a lot in our studies and absolutely we see in the field is time. So particularly iteration time and feedback time. If you're an ML engineer and you really don't get results back from experimentation for weeks at a time, it's very hard to have a productive and reliable engineering environment. So it's really a big challenge in getting a good ML engineering pipeline going, is getting the feedback to the people who are involved in the pipeline, moving really fast at a good cadence with all the right version management and control, so you know which metrics apply to which versions of what's been deployed when. So all that stuff around kind of time management, and by time I also mean version management, really important. And then the last point I'll make is a bit of a meta point, which is context and application matter a ton. So if you're doing self-driving car sorts of applications, you have very different tolerances than if you're doing a chatbot or something like that. Those tolerances lead to very different engineering pipelines, right? So you might do quite a lot of simulation if you're in the physical world with a medical device or a car and so on, whereas you might do very much more of an agile development kind of thing if you're building a recommender system or a chatbot where you launch it and you build the airplane in the air, so to speak. And those are very different challenges. And so when we talk about this stuff, it's important to remember that the application context drives almost everything.
Of course, you guys all said a bunch of stuff like tracking experiments and tracking time and feedback and context. And to me, I just heard metadata every single time you said it. But yes, these are obviously the higher level concepts that these pipelines need accurately tracked. So great conversation. I think we covered like a lot of ground, all the way from data quality to stakes and domains and which areas need what, to kind of understanding what is the most important factor that we need to be prioritizing, which actually is true for all software engineering, which is iteration speed. The time to build a new feature, ship it, and then understand how it's doing is kind of the most important thing that actually leads to productive improvements. Cool.
One other thing I just want to add is, in the new world of Gen AI, given a lot of these things are done through prompting, the reproducibility of things also becomes a challenging thing. Like, so how do you create a metadata environment where you can actually treat prompting as code and then ensure there is reproducibility? I think that's a very big challenge as well. So anyway,
Absolutely, yes. In fact, when we did a little survey of some of our open source adopters as well as kind of our customer base, and we asked them, what are the things that they didn't find in DataHub's metadata model that they would like? Prompts were up there on the list, as were fine-tuned models and getting lineage and things like that. So yes, those are becoming things that we earlier didn't talk about much. Cool. On to our second question, which is similar. What is getting in the way of AI going to production? But let's talk about governance. So what are kind of the governance considerations? We just talked about reliability. So let's talk now about safety or governance. Say, what are the capabilities in governance that are keeping us from moving AI to production quicker? And inversely, what are the opportunities or approaches that you're seeing that are actually working in the field? And a corollary question that I had seen come up quite often is, do you think this exclusively applies to Gen AI applications, or does it also apply to classical ML techniques or classical ML applications? So maybe we'll start with Teresa this time, and you're in the field implementing so many data stacks and analytics and AI stacks now. So tell us what you're seeing on the governance space.
Yeah, we've done over 1,800 generative AI implementations to date, right? So we've got some experience. In that, governance and specifically business accountability is one of the key differences between this era of AI and data than even 2 years ago. Possibly in 2023, a lot of us were busy understanding what does this impact of Gen AI actually mean to the things that we do. So possibly why we didn't have metadata day then. But happy to come back to say that it hasn't changed, right? As data practitioners, AI practitioners, we know that the business value, just like any other software implementation or any other real product implementation that we create, that's still really key. I think what's different now in when we talk about AI governance, it's no longer just something that the data team or the ML engineers do, right? It's something that the whole business really needs to take ownership of, because if you do make a mistake, Deepak, you mentioned agents being directly customer facing. Alex, you mentioned having to invest in the data to make sure we have the guardrails. How do you make sure you right size these investments? Usually all of this is around cost, right? A lot of tech and IT has been cost limited. And so you haven't had the capacity to be able to invest what you need to do to be tap into the value or to be safe. The great news and why we were so busy last year is as practitioners, finally, right, our business, the C-suite, the market, they get why data and AI is so critical. It is a competitive advantage for the company, and any AI ambition needs that data investment to be unlocked. So I think some of the changes with governance, one is the change where we do want this to be much more of a community of excellence that moves beyond the data team, right? Certainly your data leaders are going to tell you what you need to do, but that's a design authority that needs to then be spread across the rest of the company. Your business leaders need to understand your opportunities and risks, including their accountability. So don't just complain, I don't have the data that I need to drive my projects. And in fact, we found in a survey that we did of 2,000 CXOs, 48% of them who are trying to do generative AI don't have the data quality that they need to be able to do that. So they get, right, this is a business limiting issue. So they need to now invest in that. And then the other part of it is really, again, pushing that governance down into, this is something that everybody needs to do, right? It's not just your data practitioners and AI leads. So we know how to do this, again, for data. We know how to do it for model ops,
Do we?
right? MLOps. Well, I think there's actually a literature around it, right? And whether people are doing it at scale and in practice, I think people like you and Joe, right? LinkedIn is a great model I always use as to say, LinkedIn or these digital natives, they have figured out some of the tools, processes, roles that the people have. I don't think we've seen them adopted at enterprise level as much. And this is a great time to lean in because of all this interest, right? This is the best time to understand if you're in marketing, some of your job, frankly, is data governance. You're understanding this is the most recent marketing material, and that changes. It is working with the agentic system and acting almost like a domain coach to say, when I'm generating content for marketing, here's the tone. Like Accenture marketing has a particular type of language and the things that we like to highlight if we're creating a social media post versus if we're creating a part to the market. So all of these are what you might have thought of as data governance or AI governance type tasks. And now we're seeing that need to be done with everybody. I think the scary part is around the risks that these apps create, right? People on the side of desk can use any of these apps. ChatGPT is quite famous, where companies without that right governance and training, you might have well-meaning individuals, software engineers, possibly using it, and then you find that your data was leaked, right, in a way that was unintended. So this is really critical to get right.
Cool. So Teresa, I think one of the things I heard in some of the activity that you mentioned is some of the data governance initiatives that were always stuck kind of in the musty corridors of the central data governance team is kind of getting activated because of AI initiatives not being able to hit production, and kind of when they follow that thread of the why. Of course, one side of the why is data quality, and the other side of it is lack of governance. And so there's executive initiative to kind of fix both at the same time.
100%. We've been talking about data products for a long time as a industry. And I don't necessarily mean data products specifically for analytics workloads, but this thought that just like any other real product has a value to it, so you could right-size investment, it's safe, it's trusted. I trust that you as a product company have done all those checks so that you know that it works and it has a value in terms of the job to be done. That type of thinking we haven't traditionally applied at scale in data and AI. And we've been trying to do that. I think as an industry, we've been moving that direction. Now you have your CEO and your board asking you, right? Like,
Right.
do we have data to make our decisions? And I think that's a great time to lean in.
Cool. So Deepak, you've been in the so-called digital native companies, and let's hear from you.
Yeah, and
Did you prioritize governance in your early days as an AI leader, and has that changed over time for you?
Yeah, so if I look at my LinkedIn days, some of it had started coming to us, if you recall, through GDPR, right? So GDPR was the first time when we had to seriously think about AI governance, because there are data access controls. Not everyone can use every kind of data. Then what kind of data can be used for what kind of model, for what kind of applications? This is where, and then even in GDPR, we had to start thinking about how these models are used for different use cases and all of that stuff, right? So that's when I think it started coming. But I think with the advent of Gen AI, it has hit us in a very big way. And as my role as Chief AI Officer, I think about it all the time. So look, before we get into governance, a few high-level thing I wanted to say based on all my experience doing it at Pinterest for the last 2 years. I think number one, governance cannot succeed without transforming the culture of the company, right? So you can create as much governance as you want, but if that culture, AI culture, is not there at the company, if it is not encoded in the culture, it is very hard to succeed, because creating AI governance is not just an AI team's job or engineering job or a product job. The entire company has to be aligned with you, right? Whether it's legal, whether it's marketing. So one thing we did very early on was create more like an oversight group at the company. And this oversight group consisted of very cross-functional team members. Some were sponsors from the executive team. Then we had a representative from marketing, from recruiting, even from sales, because they're all consumers of Gen AI, if you will, security. So that cross-functional group needs to meet every once at least a quarter, if not more, and then kind of think about these topics in a very strategic way. So that helps a lot. The second thing you need to do is articulate your AI principles, right? Like what is good, what is not, and typically that articulation should be simple and easy to understand. Now that's easier said than done. That's why you need that council and cross-functional group. So once you have done that, then you have to put processes in place in the governance area so that every team can easily comply with that. Because guess what? If you don't do that, you can put a lot of governance in place, but you have to stifle innovation in the company.
That's right.
You want to balance governance with the speed of innovation. So what we have found work very well is to build tooling which makes it very easy for teams to follow some of these guidelines, right? So for instance, we have centralized all the tooling that is required for anyone at Pinterest to use Gen AI. And like, people cannot just go to the laptop and start calling ChatGPT. That's not allowed. If you have to use any foundation model for anything, you have to go through the central hub, right? Because that's all secure and vetted and the data is all good. So that's something that was built right on day one before we even embarked on the Gen AI journey. Then there are tools, like if we have policies, do not show any Gen AI content that describes people or images, let's say, in language that is not inclusive, right? Inclusivity and emotional well-being is a very important cornerstone of Pinterest, right? So we don't want Gen AI to be describing people that does not feel inclusive. But then how do you enforce such a policy? I mean, this is something that I broadly defined. So now you have to distill it down. Okay, what does it mean to be inclusive or not inclusive? What are the attributes, and how can you build classifiers that can detect what is the filtering rate? How much can you overfilter? How much can you recall? These are all things that are details but are very important to establish so that every team can follow these things in a systematic way. And finally, I think having some lightweight review process built into the development process is also very important, because in such a large ecosystem, things can go wrong inadvertently, right? So for instance, we have controls where if you're launching any Gen AI user-facing feature, because that's the most risky one, you need, before you even approve your experiment, you need to declare that and have a link to some certification where the review has already happened, right? Without that, you cannot even launch that experiment. So yes, it is a bit of a hindrance in terms of the development process, but a worthy price to pay so that you actually do things in a safe way. So I often like to tell the teams, like, we don't have to be the first to produce nuclear energy, but we should be the first to produce safe nuclear energy, right? And that's
a great.
that's really how the AI governance should work and has to work, given where we are with Gen AI and how important Gen AI is, especially when it comes to user-facing product, where the risk amplifies significantly compared to when you're using it in the back end.
And curious, Deepak, are you seeing that same kind of principles now being applied to classical ML pipelines as well? I presume they still exist.
Yeah. So what I just described, let's say, take that example. You can't describe something without being inclusive. In the past, a lot of that descriptions were produced by using classical AI. So we are applying the same classifiers and same tool to the classical AI output as well, and finding that there are cases where it was absolutely not very inclusive, and changing that as well. So in some sense, although Gen AI has facilitated or forced us to do this, it is actually benefiting even traditional AI solutions that are out there, legacy systems. You can revamp all of that stuff and make everything much safer and responsible.
That's very cool. And in fact, that just, when you were talking about pushing down those governance policies into how software gets developed, it kind of reminded me of the Pinterest data team. I don't know how closely the AI team and the data team work together, but actually the Pinterest data team that is in charge of the behavioral events that are emitted by the product, they actually came to the Data Hub Town Hall and presented how they have invested in essentially encoding a lot of metadata alongside their thrift schemas. And so they have a very strong documentation or metadata shift left kind of strategy where all of the classifications and things like that are basically known to developers.
We have this system
which is very cool.
PinCat and all that. So we all utilize all of that. Yes.
Yeah. So that's pretty cool to see that those kind of themes playing out. All right. As predicted, this panel is getting very interesting. We have 3 more questions that we wanted to go through. So let's see. The next one, which I had for you guys, was around model interpretability. There's a lot of focus in the industry around sometimes building complex black box AI models that sometimes outperform the more simpler to understand ones. And I'm not an AI practitioner. I'm kind of learning with the group here. So how do you find organizations balancing this need between understanding why the model is working the way it's working with kind of some of the crazy performance that black box AI models can provide? So maybe Alex, you'd like to take that one?
So interpretability was a nightmare for traditional ML, and it's an incredible nightmare for Gen AI. And also, anybody who's building, Gen AI applications either has to go through the huge pain of pre-training themselves, which is very, very, very expensive, and only 2 or 3 organizations can do it. And even when Meta releases the weights of these models, they never release the data sets. We have made a very big effort in academia to release also pre-training data sets. And there's very few teams in academia and open source community doing that. But if you just take a model and you're fine-tuning it or trying to do a RAG system on it, and you make it user-facing, that is a very, very challenging thing to do right now. I think that to do clustering and evaluation or understand what's going on in such systems, I guess one thing we have learned or we're learning is you have to cluster the types of questions your user are asking, and you have to run your evaluation separately for different types of questions. Just to give something concrete, we are seeing, for example, for IT support chatbots, internally facing, by the way, like externally facing is infinitely more complex, but internally facing, people ask, how do I change my password? What's Joe's email? So when you have a question like that, that's a straightforward RAG application, straightforward to evaluate, no problem. When you ask about the process, how do I change my password? Usually there's 3 ways to change the password, and then your evaluation mechanism may score you incorrectly. Should you produce all 3? Should you produce a connected one? And then there's questions like, can I wear Crocs to work? For example,
that's an important one, actually. Very important.
Yeah. And then what you have to do is you have to realize that for questions like this, you don't have the data in your knowledge base to answer this question. So you have to say, you run some clustering algorithm on the questions that your users have asked. You realize there's 5 types of questions. And then you say, okay, I have to add metadata, or I have to do some post-training to improve this type of question if the value of these questions is worth it for my team. So again, I think this will be systems that will be being built with a constant monitoring. I think Joe also pointed out. And I think different types of questions will need different evals. You cannot just have a single eval that's going to work. And then if you have adversarial users, if you have a user-facing chatbot, it's the Wild West out there. You may see on Twitter, people will produce incomprehensible strings that will jailbreak any model that's out there that I know. And it can extract training data. It can tell you how to make, explosives and all those things. And this is an open problem in research right now. So I don't think there's going to be any easy way that we will have a general user-facing bot, unless you have, a team of 100 AI PhDs who are constantly hunting down. And that's what I think the big labs are doing. And still, I think it's a very challenging space.
Cool. Joe, I think you face as many of these kind of challenges as part of, the Run LLM suite of capabilities. I mean, we have deployed it on the Data Hub open source Slack, and it's doing a pretty reasonable job, I have to say, in terms of responding to questions, sometimes better than core engineers can. So I'm curious what work went into getting it there, and how do you internally look at interpretability of the model itself?
Yeah, happy to address those. I think Alex made a really important shift from interpretability to evaluation. I think we're just at the point now where the idea that somehow we were going to explain what these models are doing is past. It's not like a decision tree is going to be handed out to explain what's going on. We really never expected IT administrators to understand what these machine learning models are doing. They're too complex. So evaluation, I think, is the watchword. And I like to think of it in terms of grounding and bounding. All right. And what do I mean by that? So grounded answers are answers that have reference to true facts. And in retrieval aware generation, so where you're retrieving documents, essentially, that to me is like the basics. And at Run LLM, that's what we're doing for a large part of our work is customer facing. They come out and say, how do I get Data Hub to do X, Y, and Z? We will never give an answer unless we can give a citation. Okay. And just doing that and then building pipelines of models that allow you to give a crisp answer with a citation and reject other things goes a very long way. So this includes fine tuning. It includes some rules. There's a whole bunch of stuff, a lot of data prep to get to this quality. But the point is, you don't just open the API to OpenAI and just let it do what you want, right? You ground your answers, and that's part of your pipeline. So that's grounding. Can you present the facts that this answer is based on? And in a chatbot environment where a human is validating that was what was useful, that's great. So retrieval's like a kind of nice sandbox for evaluation. And you can also see whether people are clicking through on those links that you give them, whether they're finding things useful on ratings. So there's sort of end user product satisfaction metrics that you want to track. The other thing that you do, but this still is in the realm more of research, is what I call bounding, which is if you can't give specific evidence for the answer, give a constraint on the set of possible things that are in the answer. And I'll give you a concrete example from the coding environment, from something like Copilot. If Copilot generates code for a language like, say, Rust, a strongly typed language, the compiler will tell you if it's a legal program. All right. There's a set of legal programs, and there's a lot of strings that are not legal Rust programs. And because it's so strongly typed, actually, oftentimes a legal program is a correct program in a lot of senses. If you actually write code in a language like Rust, once your types work out, you usually have things working. So that's sort of an example of using traditional logic tools, namely a type system or a compiler, to bound whether you're going to give outputs that are even reasonable. But you can imagine that being much richer. You might say something like, I only want outputs that are a valid reflection of the finances of the company, where the finances of the company are determined by, say, some formula or something like that. So you're going to check this formula on every output. It could be a logic formula, right? So it could be quite rich. You could use a theorem prover to do it. So I think these kind of automated checks are all in the realm of bounding the possible outputs you'll put to a space that is considered to meet spec, right? So grounding and bounding to me is like the way we want to think about evaluation in terms of getting to correctness. And then metrics, obviously, where you look at clusters of things and how are they performing, you break your metrics down, I think is really important in the engineering cycle as well.
And then, of course, we have to figure out how to do it in 100 milliseconds or less.
Yeah.
Which makes it all very interesting.
Yeah, one thought I want to add here. So again, I'm not in academia, but in my past life, I have been involved a lot in academia. And what we have observed is, like, take the Netflix challenge, for instance, that kind of completely changed the whole field of recommender system because there was a benchmark data set. ImageNet is another example. It feels to me like we are in this Gen AI area, in this Gen AI age, we need very big benchmark data sets that can be released so that a lot of scientific progress could be made on this, right? Like, if you even look at the area of NLP, like automatic story generation, things like that. How do you even know whether LLMs are following instructions and things like that? So some work has started emerging, but I wonder if there should be some big effort to create a very comprehensive evaluation benchmark that can then be released so that we can make more progress in this area than what one of us or few of us can make, similar to what happened with Netflix and ImageNet.
So there is a bunch of work at Berkeley. I'm not personally involved, but my colleague Joey Gonzalez is running the LM-SIS benchmarks for LLMs and trying to build up, iteratively community goals and benchmarks for the LLM space. And I think one of the places that they're getting to with this is that for science, these benchmarks are helpful because they do push the field forward, but specificity is so poor in this domain and the ways these LLMs get deployed is so varied. That in production, a lot of these benchmarks are misleading, if not entirely unhelpful. And so I actually think we're going to move from a realm of these kind of general benchmarks to push science forward into some more narrow benchmarks and also evaluation methodologies so that if you're deploying a product in a particular vertical to do a particular thing for particular customers, you have a methodology. These benchmarks they're pretty coarse-grained. And, even if you go back to benchmarking, like the performance of a database on a workload, right? Those benchmarks also, they served a purpose for a while, but now if somebody reports their TPCC numbers, you should take a very deep breath and a large grain of salt because that may not help you in your workload.
If I may add something, there's great work indeed from LM-SIS from Berkeley on this. I think we will have benchmarks and then we'll have live benchmarks where the benchmark constantly changes. And then we will actually have another LLM.
Yes.
Right. So what I think actually because every time you release a benchmark, somebody's going to train on it and crush the leaderboard because there's an incentive to contaminate, right? If you're buying your vendors based on a benchmark, of course your vendors are going to contaminate the data set. So by definition, there's a conflict of interest. So Netflix already held something out. So there's a ways you can do some holdout. But I think what's going to happen is you will have specialized models that will be the evaluators, and there will be adaptive multi-turn, and that's how I think you will be.
Yeah, I mean that is happening now. That's absolutely where things are going. Yeah. Those leaderboards are often judged by LLMs. Yeah.
I think that's a very good point, right? Kind of vertical specific benchmark and all, like, because boiling the ocean here is like the ocean is too big to kind of boil.
Yeah. That's very interesting. I'm looking forward to seeing if those domain-specific data sets can be a thing. It'll actually open up so many avenues for folks. Cool. So we went very deep on kind of AI-specific stuff. We're going to go back to engineering for a moment. We talked about iteration speed as being something that we care about. The faster you can iterate, the faster you can improve. So let's talk about what do you see are kind of the biggest needs for balancing both this rapid iteration or velocity with also ensuring kind of proper versioning and visibility into all of your machine learning evolution. I mean, I guess people call it the MLOps category to keep it simple. But what are you seeing working out in your deployments? And again, since Teresa, you're kind of at the forefront of, what is it, 18,000 or 1,800?
1,800. Hopefully I didn't say
Okay.
1,000.
Next year it'll be 18,000. Okay. So 1,800 deployments. Tell us a little bit about what you're seeing with respect to kind of balancing, the 3 V's. Actually, Joe, borrowing a term from your paper, the 3 V's of MLOps, right? Velocity, versioning, and visibility.
Well, I think this is where we do have lessons within software engineering, as you've been alluding to all along, and that requires your tooling, your tools, your processes, your people, right? And I think we've spent some time talking about the people side. I do want to kind of pick up on the last discussion about some of the tooling, right? So the tooling that you need to be able to, one, check your data, that the data is accurate, and that starts with things around the metadata. It's the lineage, it's the quality, it's the governance of that, right? I need to know that Shashanka says, yes, this data is allowed to be used. I can be able to track this data for regardless of source to target. I'm going to be able to right size the investment and the cost, right? I know if the quality changes, that all the use cases downstream can be undeployed or can change, right, based off of what's needed. So I think that's one part of it. I think we talked about some new capabilities here, right? Things around looking at model accuracy. And we definitely did that with traditional MLOps, right? The more predictive and prescriptive type of AI. But I think with this new type of AI moving towards, I think what Alex, you were talking about, being able to just check if it's, you're going to need to evaluate it, right? So you're not going to be able to know ahead of time what's there. And I think it does go back to why that data is so important in getting it right. So we talked about things like Chatbot Arena, LLM Sys, right, just beforehand, about being able to have almost a benchmark and a leaderboard. You could create your own, custom benchmarking for your use cases, and you're going to bootstrap that using something like the Chatbot Arena, right? This is a place where your users, as they're prompting, you can see what's accurate, what's might not be accurate, and then you use that to bootstrap, and you're going to bootstrap and eventually get a corpus of data. You might hear you also use synthetic data and any data that you have and a domain expert to be able to fill out all those gaps. So if I continue leaning in on Joe's example about maybe things around code, if there's a new Python vulnerability that comes out tomorrow, I don't need to wait until that propagates through the system. A domain expert can actually put in all the question answer pairs, possibly using Gen AI to create all those that corpus of data that you're going to use to be able to now measure, in this case, Gen AI, right? Is it going to be accurate or not? And if it's not, right, like it might be, you have to then engineer around it so that you don't propagate that vulnerability in what you're doing. So I think some of those tools, right, the things that I mentioned, we knew how to do. I don't know that we've done it at scale, right? Things around good data governance, good MLOps practices, having the right metadata. So it's not just written on paper, but all of what I just described is automatic, right? Even in the new case where when I hit a prompt, automatically, if it's not good, then that's also feeding back into that database, right? So all of that is something that is just really augmenting what we've done with MLOps.
Cool. And Joe, I think as one of the original creators of the ground paper, you've had a long history with thinking about versioning and these kind of concepts more deeply. So I'm curious to hear, as your research has evolved in parallel with your commercial ventures, how have you seen the field evolve, and what do you think are today's best practices around enabling MLOps? Like, how painful does it have to be for someone to do this?
Well, I certainly gained some humility trying to build product in this space. Before Run LLM was doing what it was doing, it was trying to build MLOps pipelines, and it was very difficult to build the right thing that would make many people happy. And to a large degree, most shops are doing it themselves and not ready to adopt tools, I think, for this sort of pipeline. So we're not going to see standardization of the tool chain, I don't think. And that's okay. That's where we are right now. I mean, that was, as I say, a humble learning experience. We couldn't walk out with the perfect tool because it doesn't exist right now. Having said that, the ground project, was an early effort to do a metadata system that, Shashanka, you participated in. I think it informed the design of Data Hub. After ground, we built a system we're calling Floor, which goes above ground. Flor, though, is a pun in Spanish. It's F-L-O-R, which is a flower growing out of the ground. Anyway, the key with Flor is to think about logging as the primary generator of metadata. Okay, so what can you get an ML engineer to do to generate metadata? They will not sit with the tool and configure it. They will not register a bunch of stuff, but they will put a log statement into their code if they need something to come out of their training or inference code or their data wrangling code. So let's embrace that. Let's consider metadata is anything that you can log, which really is the state of any computation, right? So that's step one, is to just embrace the log and then make it easy to do log analytics, because everybody does that. Step two then, and this is where the Floor technology comes in, is to make logging retrospective. So we have this idea called hindsight logging, where you can actually take a run of a Python training script that you ran 2 weeks ago that took 6 hours, add a log statement to it, and as if that log statement was there the first time, you get your log without rerunning your 6-hour training script. And this is done by checkpointing and some clever stuff where you just do a differential execution to generate the log statements. But with this Floor hindsight logging technology, because any log statement generates metadata, and you can make log statements happen in the past that weren't there to begin with, you can now start querying the past. You can query all your old scripts. You can query all your old training runs. You can query all your old data wrangling scripts and find out things about them that you didn't record at the time. So if I give you a magic box that lets you get metadata post hoc, now you can buy damage, because you can really query everything over all time, including in the past. And now it's a question of what do you want to know instead of what did you record?
That is pretty cool. Pretty cool. I'll have to look into that. Actually, I was nodding furiously along as you said, ML engineers will not adopt a tool, but if they have to log something, they'll do it. Because actually data engineers are very similar. When we look at even integrating with basic systems like Airflow, Airflow is a basic orchestrator. And you say, well, I need to get metadata out of it. The 9 times out of 10, we find our both open source as well as commercial customers just taking the Data Hub SDK, and we've got some very simple emitters that we've built over the years. They just drop those in as part of their DAG and say, okay, it's fine. It's just emitting one more thing. No harm. Like, I'm not having to change how I think about my DAG. I don't have to change how I'm thinking about how I want to organize my code. It's just a log statement. I mean, sure, we think of it more like structured logging, where the metadata that comes out is not just strings that we have to parse later, but they're actually types and aspects and entities, and there's some relationships and concepts that we can then make it easier. But yes, that is where we are seeing pretty much everyone going to. And to your point about querying the past, absolutely, that's the number one thing we see happen, where you deploy into an enterprise and they're not going to say, well, we're going to run you for a month and then hopefully our lineage starts to improve. It's always, what can you tell me in the first week that I didn't know before? And so it always starts with being able to go into the past. And usually that ends up being the query logs and the audit logs and all of the logs that exist. But if you've cracked the holy grail of actually being able to even go into partially checkpointed compute state and extracting metadata from that, that would be super cool. That would be super cool. So, all right, we are on to our last question. We talked about iteration speed. But let's kind of take a slightly longer look. I mean, last year has been kind of crazy for all of us, year and a half. As Teresa said, we were busy understanding this new wave. But if you take a big step back and think about, how the last decade was, and then how the last year and a half was, kind of like a very accelerated change, and then you had to make predictions for the next 18 months, what are the things that you think are okay to change and are most likely to change? And what are the things that you think are going to pretty much stay constant? And so since we only have 5 minutes left, and I want to have the audience also be able to ask questions and use the chat for that, let's do a quick bullet round of questions and answers, bullet points only, starting with Deepak first.
Yeah, I think the models will keep changing and they will evolve at a very fast rate. And so what I think should remain and will remain the same, in my opinion, is federation of models and centralization of process and tools. So those would not change, and those should not change. They should remain the same so that we can continue to make progress.
Cool. Over to you, Teresa.
I think we'll see a lot more of the small language models. So everybody's been using the managed models, and the requirement is getting your data right. The good news is you can use Gen AI. I talked about synthetic data, possibly tapping into your unstructured data. So how you're going to be able to get it right is not going to be how you had to get it right before. So very exciting time to be in data.
And then how about you, Alex?
Yeah, small models, specialized. So I think small specialized models is one thing that will do small jobs in a predictable way. And also when people say synthetic data, I think we'll see synthetic plus real data pipelines. So prompt an LLM to transform. So it won't be just pure synthetic data. It will be synthetic plus real data pipelines that will be guiding augmentation and control.
And then over to you, Joe. Your parting thoughts on?
Yeah, I think the biggest changes that I'm looking forward to are at the user interface level in a bunch of ways. One of them is I think we're going to see increasing coupling of recommendations from AI models with static checking outside the model in this kind of bounding space. It's crazy to me, for example, that Copilot will generate code that doesn't compile. They have compiler technology. It's not like they don't know how to do it, right? So I think we'll see more of that. But I also think we're going to be seeing this technology used in ways that we haven't quite anticipated yet, much more aggressively. And so the chatbot sort of frame of mind will pass, and we'll be much more into how do you review code? How do you review data? How do you review the behavior of a robot, right? And these are going to be very different than, is my chatbot hallucinating text? So I believe that's where a ton of the innovation is at that AI meets HCI layer. And I'm looking forward to that. I think there's lots of room for cleverness.
What about things that you don't think are going to change?
Everything's changing, man. I do think, data management actually is the key one that won't change, and governance will not change in the sense that the legislative infrastructures of the world move very slowly. So that is, of course, causing a ton of friction. The rates of change are so different.
Cool. I fully agree with pretty much everything I've heard and learned a lot today. It's been a great conversation. Hopefully the audience also learned and started thinking about new things today after hearing all these experts speak. I definitely think reliability considerations and governance considerations around both data and AI will continue to stay kind of an important thing that we'll have to stay ahead of, despite all of the innovation that happens. And sometimes the innovation will help us, like we talked about LLMs being able to judge the outputs of stuff, and then they'll probably help us govern better. They might help us assert quality better, do the grounding and the bounding as well. But we have the questions going in the chat, so feel free to ask your toughest questions, and our panelists are around for a bit to be able to take some of these questions and answer. But first of all, thank you so much for spending a good 1 hour with us talking about all these things. Teresa, Deepak, Joe, and Alex, I know you're all super busy folks, so thank you so much for spending time with us. And to our audience, I hope you had a great time listening to these speakers, and feel free to connect with them.